Okay, today is about permutations. For permutations and combinations, let me try to explain them this way. All right, I have three things out on my desk here. I have a remote, I have a die, and just keep it simple, I'll make it three different things. And I will use this marker here, okay? Remote, and the die, and the marker. Okay, now, if I have these three things, do you get that I can take out little subsets of them? Like I can just take out the die and the marker, okay? And then how many little sets can I make out of these three things? How many sets of two? Well, I could put the die and the marker, and here's the question. If I say die and the marker, is that different than if I switch them around, the marker and then the die? Okay, if that matters, then the order matters. But do you get for a lot of people, in a lot of situations, it doesn't matter if it's marker and then die or die and then marker. It doesn't really matter. The order doesn't really matter. Like if I'm going to pick two people to help me clean up the floor later, okay, if I say, okay, it's going to be you and you, does it really matter what order I pick them in? Okay, if I get to get Bob and Susie, it doesn't matter if it's Susie Bob or Bob Susie, it doesn't matter. So there's a lot of problems where order doesn't matter, and there's a lot of problems where it does matter. Like, when would order really, really matter? Well, when you're picking for president and vice president, then there's definitely a big difference. One of them actually gets to have the nuclear codes and the nuclear football and know all the secrets of our country, and the other one doesn't. Although I wonder to what extent, I suppose they share whatever they want to share with the vice president. So can you imagine if you're the commander-in-chief of the United States, as in you're the boss of everything, can you imagine how many secrets there are that they don't tell everybody? But you get to know. You don't get to know everything about everything, but because I'm sure that there are probably things where you just, like the president doesn't need to know that you have 17 ponies in the stable over underneath the White House or whatever to bring out just in case of there's a nuclear attack and they have to be able to get away quick and all electronics don't work anymore. Anyway. Ponies. Anyway, so the order matters when it's contests, like first place, second place, third place. I mean, you know that those Olympians, they really want the first place. I mean, they'd be better with second place than nothing, but they want first place or second place or third place. Those are the big three. So if I, for instance, was running a race, if all of us were to go out in the parking lot and race across the parking lot, and the person who gets to the end first gets to have the mountain of meat sandwich here. No. But if we were, and first, second, and third place all got prizes, obviously, then keeping track of these three kids won isn't good enough. It's who won first, who won second, and who won third. Then the order matters. Okay, so I just want to get across that order matters is a big deal. And permutations is where order patters. Get what I did there? It's going to be your way of remembering that permutation, the order matters. Okay, permutation, the order matters. Combinations, the order doesn't matter. So if I asked you how many combinations of kids could I pick to be on a committee, again, a committee is a classic case where it doesn't really matter. You're on the prom committee, you're going to help out with the prom, and that doesn't mean you're the boss or second place or whatever. You're not. It's just order doesn't matter in that case. All right, permutations, the order does matter, and that would be like, again, first place, second place, third place, or lining up. How about this? Who gets to kick first when we play kickball outside? First place, second place, third place. Does that make it a big deal like in a baseball game? The batting order? Yeah, it's kind of a big deal. They really pay attention to that because if you screw that up and you put your really good batter like last, that's really stupid because they won't get up as many times. Then when they do get up, they don't have as many people in front of or after them to like bat them in and stuff. So anyway, order really matters sometimes. Those are P's. And here's how it works. If I had 5 people, P2, that means I have 5 people and I'm picking out groups of 2 where the order matters. Order matters. Okay? So if the order matters, you use the P. And if it doesn't matter, you use the C. This would be 5C2, and that's where I have 5 people, and I'm taking out groups of 2 where the order does not matter, like for a committee, as opposed to a race where order would matter. Okay, so then that's the little formula. Now, actually, we can actually figure these out without a calculator. There's a way to do this without, but there's also a way with. So grab your graphing calculator, and I'm going to show you both. Do you know what the thing, while you're getting your calculator out, you can think, do you know what the thing with the exclamation mark after it is called? Like if I said 5 exclamation mark? There's a math thing for that. Have you ever heard of it? 5 exclamation mark? It's called 5 factorial. And I'd like you to find that. It's on your calculator. It's under the math. Just first type in a 5. Okay, everybody type in a 5. And then we have to get the exclamation mark. It's under math, and then you arrow over to PRB because those stand for probabilities. Do you see the exclamation mark? So type in 5 exclamation mark and tell me what it is. 120. Now, does anybody know what it just did? Yes, sir. 5 times 4 times 3 times 2 times 1. That's exactly it. That's what they did. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. Yes, that's called factorial. I learned something new today. Just hold on. This answer is not, okay, this answer is not 120, by the way. I just did 5 factorial. But let me just finish this. And yes, 6 factorial would be 6 times 5 times 4 times 3 times 2. 90 factorial would be 90 times 89 times 88 times 87. You got to go all the way back down to 0. Actually, you know, wouldn't go to 0 because then you'd just make this whole thing turn into 0. But anyway, go down to 1. So this formula is, everybody write this down because you're not going to have this like automatically memorized. It's going to be 5 factorial over 5 minus 2 factorial, which in this case is 5 minus 2 is 3 factorial. And that's your formula for figuring out how many combinations there are. 5 factorial over 5 minus 2 factorial. All right. Now I want you to actually use this. We already figured this one out, 120. Would you use that factorial button? Or no, why don't you just use your brain? What does 3 factorial mean? 3 times 2 times 1, which is 6. So it's really it's 120 divided by 6. Can you do that in your head? I can. I can do a little canceling. This is 6 times what? 20. And then the 6's will cancel, and the answer is 20. What does that mean? There are 20 what? Possibilities. If you have 5 kids, for instance, and you're picking out sets of 2 where the order matters, then there would be a total of 20 combos. Just to clarify, if it's Bob, Sue, Bob and Sue is a combo, then Sue and Bob is a different combo. Why? Because the order matters. Bob's president, Sue's vice president, or Sue's president, Bob's vice president. And they're different because the order matters. Okay. So that's where order matters. How about if order doesn't matter? Well, then there's a different formula for that. So this one is exactly the same as the other one. 5 factorial over 3 factorial. And of course, if it were exactly the same, then the answer would be the same, but that doesn't make sense. If the order doesn't matter, just think for a second. If I've got groups like Bob, Sue, and Sue, Bob, and Bob, Sue are exactly the same, if it doesn't matter what order they're in, then should there be less or more combos? Less combos. Because all these combos had to get rearranged to make our 20. You know, Sue, Bob turns into Bob, Sue. They all can go backwards, and so there's twice as many. All right, so if we want less for the combos because the order doesn't matter, then there's an extra thing here on the bottom. Anybody want to take a shot at what it is? It's really simple. 2 factorial. Somebody said it. Why? And that's divided by 2. 2 factorial is the same as 2, isn't it? But here's the simple thing. It's this number, whatever it is. So if this had been 5c3, you would have put an extra 3 factorial on the bottom. All right. Don't think that through super hard. It's just the same formula as the other formula, except with an extra thing on the bottom, because when you divide by something, it'll make it a little smaller, and the combos should be smaller number of things, because the combos, the order doesn't matter. All right, so if you understood that, tell me what 6c3 is using factorials. What goes on top? 6 factorial. And on the bottom, 6 minus 3 factorial, which is 3 factorial. And an extra one of those. 6 factorial over 3 factorial, 3 factorial. Now, you've got a calculator, and I know you can just use a calculator to do this, but let me show you something cool. Do you get 6 factorial really means that? 6, 5, 4, 3, 2, 1. And 3 factorial really means this. And there's a couple of them. Guess what I'm going to do? Cancel. 3 times 2 times 1 cancels. 3 times 2 times 1. 3 times 2 is 6, right? And that cancels the 6. 5 times 4 is 20. But that's faster than what you did, isn't it? So factorials are pretty cool to do in your head, because you can stretch them out, cancel a whole bunch of things. Final answer, 5 times 4, which is 20. The answer was 20. Raise your hand if you got 20. Okay, good. Let me show you one last way to do it. On your calculator, there's a way to put in 6c3 directly. There's a C button. It was under PRB again. So hit 6 first. Everybody type in a 6 first, because you can't go back and do it later. You got to have a 6 first. And then go into Math, PRB, the Math button, and then PRB. I'm going to pause for a second. I'll pull that up. So if I was going to type this in directly, 6c3, I put in my 6. And then to get the C, I go to Math. I just hit the wrong button. I meant to hit the regular Math button. There we go. And then arrow over to PRB for probability. In the new operating system, it's PROB. And then I go down to C right there, 6C, NCR. And then it pops this thing up, and it wants me to put the little 3 right underneath it. Now, if yours doesn't have that neato like subscript, it's just because you don't have the new operating system. Who does have the new operating system in here? It's like, looks like mine. Okay. Listen close now. Who's got the old operating system? And look at your calculator. You've got a TI-84. You've got a TI-84, but you've got the old operating system. All right. All you guys, if you want, I can upgrade you to the new operating system if you have an 84. Okay. If you like yours and you don't have to change it, of course. But if you want the new operating system, it's kind of like, you know, Apple comes out with a new software and a new update or whatever. They don't get pushed onto your calculator, right? But I can push it onto your calculator with this cord that I have and hook it up to mine. So if you want the pretty print, which is better, it's just different and you have to get used to it, but it is better to have the newer operating system. I will give it to you if you want. All right. So there, I hit enter and it says 20. If you have the other system, it'll say NCR in the middle of your problem, and then you type the 3, and then you hit enter, and you get 20 either way. Yes? Can you explain why you do 3 twice on the bottom again? Okay. The first 3 was because it's always this number minus this number factorial. 6 minus 3 factorial. This 3 is because you always, in the C's, the combinations, you always put an extra one of those right there on the bottom. And that will effectively make your answer smaller because you're dividing by, in this case, 6. Why? Because the answer was going to be the permutation. And the permutation answer has a lot more answers because the order matters. And we want to make it smaller because the order doesn't matter anymore. All right. So, to sum it up, here is a typical question. This is actually good in the real world. Like, this could actually happen. Okay, so there's all of us, and we're going to go, and instead of doing a race, because then we could kind of like pick who's probably going to win, okay, let's say we had first, second, and third place in an art competition. Okay, some of you guys make some really cool either artwork or drawing, and then we have a little contest, like we figure out who's first, second, third place, okay? So there's how many of you? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25, my smallest class. There's 25 of you. If there's 25 of you, my question is, how would you use C's or P's to answer this question? If there's going to be first, second, and third place, how many different ways could that happen? Like you could be first, you could be second, and you could be third. Or you could be first, you could be second, and you could be third. Get what I'm saying? There's a whole bunch of different combos. In fact, you can do, was it C's or P's though? P's. P, why? Because the order mattered. 25P, and then how many places were there? 3. Use your calculator, figure it out. It's a really big number. Don't be shocked. If it's a really big number, you're doing it right. It's a ridiculously big number of combinations where, because all you'd have to do is change one thing. Even like within 3 people I picked to be first, second, and third, rearranging them so one of them's first, one second, and one's third, and then rearranging it again, rearranging it again. That's just with 3 people. And then you throw in one person different, and now you have to redo the whole thing again. And a new person that's different, and you have to do the whole thing again. And it comes up to this ridiculously big number. In fact, what did you say it was? 13,800. Yep. That's one of the reasons that phone numbers, there's a lot of people in the world, right? And there's a lot of phone numbers in the world. Now it's almost there where we have almost the same number of people as phones in the world. What? How can that be? Because a lot of people have more than one phone. A lot of people don't have any phone, but there's a lot of people with multiple phones. So if there's in the neighborhood of, let's say, 7 billion phones out there, they all need a phone number, right? You can't have it be the same. Does the order matter on a phone number? If you dial your number, even like rearrange the last 2 digits, find out if it works or not. Okay? Yes?
I get kind of confused by the phrasing. I would think that order doesn't matter in combination.
Okay, on a combination, order does not matter. On a permutation, order matters. Order does matter. Why did we do order in this case? Because it was first, second, and third place in a competition. And the competition told me we have to use a P. If it was just, I'm picking, okay, let's do one of those right now. I'm going to say in the same classroom full of 25 kids, this time I'm just going to pick like sets of 3 kids that can help me after school. Do you think the order really matters of the 3 kids? No. So then what are you going to use, P or C? Do it with your calculator and figure out the answer. 25C3. Now the order won't matter. What did you get? Because I know you were first. 2,300. All right, that's a lot smaller answer. Why is it smaller? It still sets a 3 out of the 25 people. Because the order doesn't matter anymore. If I pick 3 of you, I don't have to rearrange you and rearrange you and rearrange you again and rearrange you again. In fact, how many times could I rearrange a set of 3 people? 6 times, which happens to be 3 factorial, which is the reason that that's on the bottom in that extra little calculation by hand. This one would have been 25 factorial over 25 minus 3, which is 22 factorial. And this one would be the same thing, 25 factorial over 22 factorial, but it's smaller because we divided by an extra one of these. There we go. And if you actually do that on the calculator, it'll come out to the same thing, 2,300. All right, still a big number though. Can you imagine that there's 2,300 ways I could pick sets of 3 kids? I know it doesn't seem possible, but it's true. All right, so let's move on to what are you going to have to do with this thing? Here is a typical question. Oh, by the way, this is also a different principle that you don't have to use P's and C's to do. And I'm going to show you how to do this without P's and C's first, because I think it's actually easier. She's got 4 different shirts, 3 different pairs of pants that all matches, and they can all be worn together. Unlike, you know, Mr. Plaid and khaki guy here. They can all be worn together because they'll all match. Like, they'll all fit. All right? So, do you get that in this case there's 4 options for shirt? It's kind of like a tree, but you don't want to draw the tree for this thing because it's going to be massive. So there's a really easy way to do this. Multiply your choices. There were 4 different shirts and 3 different pairs of pants. 4 times 3 makes 12. The answer is 12. There are 12 different outfits that she can make. If you wanted the picture for this, let's say this is red pants, blue pants, green pants, and Mr. Khaki over there. Khaki pants. Then this is going to be shirts. How many different... Oh, wait, this was... Dang it, that's supposed to be shirts. These are all shirt colors then. Red, blue, green, and khaki. I got a khaki shirt. They exist. Okay, and then this other one's going to be 3 pairs of pants. Okay, and this is... I do have red pants. Have you guys seen them? All right, and then there's... And I'm patterning that after Mr. Glenn. If you're listening, Mr. Glenn, he was a teacher at my high school who wore red pants every now and then. Okay, red, blue pants like blue jeans, and let's say you have white pants because you're from Florida. All right, then do you get how this combo of the red shirt with the red pants, I'm sure that would look great together, but anyway, that's 1 outfit. Red with the blue is 2 outfits. This will be 3 outfits. And I'm going to have 3 more for this, and 3 more for this, and 3 more for that. So 3 times 4 makes 12. Do you get how it would have been a whole lot easier to just say 3 times 4? So try to remember this. You multiply choices. You multiply choices. So it's really, really, really simple. What happens if she has 4 different shirts, 3 different pants, 2 different shoes, 2 necklaces, and 1 pair of earrings? You multiply your choices together. It's that simple. 4 times 3 times 2 times 2 times 1. Because why? Because you're either going to wear the earrings or you're not. There's only 1 extra thing there. All right. So you multiply your choices. 4 times 3 times 2 times 2 times 1. Your final answer for that, 4 times 3 is 12, times 2 is 24, times 2 is 48. And you can draw a massive tree diagram, or you can just be smart about it and say, oh, there's 48. Multiply your choices. All right. Next, that's called the counting principle. And it basically just says the product of, as in multiply your choices out. Please stay with me. Stop talking. In the front row is really distracting to me. Okay. Now let's talk about license plates, because this is a different kind of problem that doesn't need P's or C's. I think this is best with blanks. Do you get how you can think of these as having a little blank and you could put anything on the blank that you wanted? In Minnesota, it used to be the letters first and then the numbers. Now it's backwards. It used to be, I know because my car was the Fez 470. That was my old license plate number. But now, it's like, I'm not going to record this on the video because people could like look me up. Let's say it's 245 NDT. Okay, now they put the numbers first and then the letters. But do you get this is about choices? There's 6 spots you can put stuff on your license plate. Actually, technically, there's 7. They just always have a blank in the middle to make it easier for the cop, who's usually the person that really needs your license plate really quick, to read. They got 3 of these and 3 of those, and they have space in between. And the memory, human beings chunk things into sets of 3 or 4 really easily. Okay, so that's why they do 2 sets of 3. You can actually have 7 things on your license plate if you buy a vanity plate. Okay, so like you can have, I used to have a vanity plate Go Epic, because I sold for an insurance company that was called Epic. And so Go Epic was my license. So you can have 7 spots on yours. You know, like you can be Doc, D-R-W-H-O. I guarantee you somebody's got Doctor Who here in Minnesota. And you guys have, your parents have a vanity plate like that? Only one of you. You willing to share what it is, or? Yeah, we probably shouldn't put it on the video anyways. Okay, hold on just a second. Okay, And there's certain license plate combos that obviously wouldn't be appropriate. Like, you know, you can think of quite a few, I'm sure, being high school kids. In fact, I'm sure you could probably have a lot of fun finding all these creative ones. Anyway, but we're not allowed to have those in Minnesota. So actually, every now and then it gets past the person because they don't catch, like, what is this weird combo of letters and numbers? And then you'll see it driving down the road like, oh, that's a naughty word, and they never even like caught it. So anyway, they try to catch it, but the person doing it is human, and every now and then someone's going to slip past. So there's 7 spots on a license plate, but we're going to keep it simple, and we're going to just do this kind that aren't vanities, and that's 6 spots. So if we're going to put 6 little dashes, and I'm going to have the numbers first because that's the way they are nowadays, numbers first and then letters, not like they are in the what is that, sunset state. What's the sunset state? Do you guys know? It's like Arizona or something? I don't know. Which one's the sunset state? Somebody could look it up. Anyway, I have how many choices for numbers for this first spot? You remember me saying before we're going to multiply choices? And some of you are thinking, he's wrong. There isn't 10 spots. But there is. How come there's not 9 numbers you could put there? 0. 1, 2, 3, 4, 5, 6, 7, 8, 9 is 9 things, but you could also put a 0 there. That makes it 10 choices for the first number. How many choices for the next number? And you multiply choices, right? And then how many choices for the next number? And then how many choices for the first letter? 26 letters in the alphabet times 26 times 26. Now, what if we said there couldn't be any repeats? Exactly, be 26, 25, 24, and 10, 9, 8. Think about that. There's 10 choices for your first number, but then there's only 9. Why is there only 9? Because you already picked one for the first spot. 10, 9, 8, and then 26 choices for your first letter, but only 25 for your next, 24 for your last. That would all get multiplied because you multiply choices.
So why did we learn the other way?
You're going to see. This is easier for this kind of problem. You'll find that for probability, when you're all done, there is like 5 different ways to do every problem. Remember me saying the one that would work for almost everything was a tree diagram? Would you like to draw the tree diagram for this? No. It would be insanity. Okay? But I'm going to call this the blanks method. Okay? Because you have little blanks and you fill them in. So if I had 5 people and they're lining up for prom, 1, 2, 3, 4, 5, and do you get that if you're doing a picture like this and there's one person that's really tall, you should probably put them where? Right in the middle. Otherwise it'll look tilted if there's one person really tall on an end. Okay, so then do you get I really only have one choice for the middle? If there was somebody tall. And how many choices do I have for the first spot? Remember, there were 5 kids. Why can't I say there's 5 choices for that first spot? The tall person has to be in the middle, so now I don't have 5 choices. How many choices for that spot? 4 times... No, they can't choose anybody because I already picked somebody and put them here. Can't have repeats of humans in the picture, right? Think about that. You can't have the same person here and here in the same shot. Okay? So 4 times 3 times 2, and how many choices do I have left for that last person? Only 1. No choices, only 1 left. I know that freaks people out, but think about it. If I have one really tall person, how many choices did I have for that middle spot? Only 1. And now I took out 1 out of my 5 people. Now there's 4 people left, so I get to pick any of the 4. I put them there. Once I put them there, I've used up 2 of my people. So now there's only 3 choices. And then how many people are left when I get here? 2 choices. If I have only had 2 choices there and I already used 1, I only have 1 person left and they go there. All right, so I'll give you one that's similar to that. If this is the one, could you do it with blanks and choices? Yes, you could. Or you could use that method that I showed you before with the P's and the C's. Again, it's your choice. You could draw a tree diagram for all of these if you want to waste your whole life. So tree diagrams are great in some situations. Blanks are great in some situations. And who can do this with a P or a C? We just started the hour with that, and hopefully your short-term memory is not that bad. I'll give you a hint. It's 5C or P 3. Which one is it? So, say it. 5P3. Because why? Because the order matters. Why does it matter? Because it's a competition, and order matters in a competition. Okay. Now, could I have done this with blanks? Absolutely. But how many blanks would there be? If we're only keeping track of first, second, and third place, there's 3 blanks. And how many choices do I have for that first place winner? How many people are running in the race? 5 people are running in the race, so there's 5 times how many are next? 4, because I already picked one for the other spot, and you can't have 2 people. A person can't finish first and second in the same race, right? Okay, 5 times 4 times 3. Guess what happens when you do 5P3? Get the same exact answer. 20 times 3, which is 60. Check it on your calculators. 5P3 equal to 60, or did I just lie to you? Was it 60? All right, cool. Do you get how you could do it either way? I know some kids don't like choices like that, but you could also make a tree diagram for this with all the names on it. Either Greg finished first, or Sam finished first, or Tyler finished first, or Patty finished first, or Sarah finished first. And then you'd have to have a branch after that for who got second. And then either, oh my gosh, it would be an insane tree, but he could do it. And you'd have 60 things on the end, 60 branches on the end. I know, because the answer is 60. All right. Now, what could have changed this so it wasn't a P? How could it have been a C problem? 3 people. We're picking 3 people. And the order of them doesn't matter. You, and you, and I don't care who's first, second, or third. It's just you, and you. You know what I mean? These 3 people, and the order doesn't matter. Then it would have been a C question. All right. So you got a choice, blanks or P's and C's. Think of them as tools, and you can pull out the right tool for the job. If you get a problem, and you're like, oh, this one, I think I'd like to do it with the blanks, because I can see it like on a license plate. There's these 5 spots on the license plate, and I can see that better, and I'll use blanks for this one. But if you're like, oh, actually, the numbers are decreasing, like 5, 4, 3, 2, okay, then that means the order matters, and then I could use a P on this problem, and you could do a P setup, and you get the same answer. All right, I'm teaching you a lot all in one day today. All right, let's do number 2 here. How many different ways can the 5 racers place if a girl needs to finish first and third? Like, think of it this way, not that they're going to say, only girls can finish first. Think of it this way. Your friend told you, I don't know who they were, but I know it was a girl was first and a girl was third. I don't know their names, but I could see it was a girl and girl. Then how many choices do I have for my first spot if it had to be a girl? 2. How many choices could it be in second place? Notice it doesn't say whether it could be girls or not, but there's only one more girl. Isn't she going to have to be at the end? Yeah. Okay, so then how many choices do I have for the end? 1. And that means I've used up all the girls now. And how many choices are there for the middle place then? 3. Those 3 guys. I would use blanks. Anytime they make restrictions on, oh, this kind of person has to be first, you can't just crank it out this way. If they say, oh, this person has to be in the middle, or this person needs to be first, then the blanks method is way better. All right, what's the last one here? The probability that a boy finishes second. Okay, did you notice up till now it was never a probability because we never divided anything? We just have a big number. That's how many ways it could happen. All right, so what's a probability? It's what you want over what's possible. I said that at the beginning, and I'm still coming back to it. Okay, probability a boy finishes second. First of all, let's figure out all the possible ways that the race could go. how many possible ways were there that the 5 racers could place? We already did that. It's number 1. You get how we already know how many different ways there are that they could finish? There's 60 different ways it could finish. So I'm going to put 60 on the bottom of my fraction. That's what's possible. How many different ways are there that a boy could finish second? How many choices do I have for this first spot? If a boy's going to finish second, if a boy is finishing second, maybe we should do second place first, and that'll help us a little bit. How many choices do I have for second place if a boy has to finish second? There's 3 boys, right? Then there's 3 choices for one of those boys has got to finish second. Then I'm going to go back and do the other ones. There's a total of 5 humans. I already used up one of my kids. He's standing right here. Now how many choices for that first spot? 4. And then I just used up another person, so how many choices for the next spot? 4 times 3 is 12. 12 times 3 is 36. How many was possible? 60. 36 ways that boys could finish second out of 60 ways possible. That is about as hardcore a probability as you can get. And frankly, the average math teacher could not answer that question. I'm not saying I'm special. I just happen to teach this unit on probability. There's quite a few math teachers here who teach this unit who could answer this question. But honestly, out of our 22 math teachers, if we sat everybody down after school today and gave them that question, out of the 5 people who actually, or 7 people who actually know how to do this, one of them would probably screw it up just because it's complicated. Okay, so then you're down, and the other one's probably, maybe half of them would guess right. So you probably only have like half of the 22 math teachers to get that one right. Serious. Probability is that weird and that hard. Okay, so it's not just like, oh, obviously. All right, that's a tough question. So don't feel bad if that was hard for you to understand. But really what it boiled down to is all the things that were possible was 60. So you put that on the bottom. And what I wanted, I needed to figure blanks out for that. And since a boy had to be second, I only had 3 choices for that. I remember my theme of multiply choices. I had to multiply these all together then.
Well, what gives you the 4? I didn't understand how you got the 4.
How did I get the 4? Okay. Would you agree that there's 5 humans that are racing? Some are boys, some are girls.
Yes.
Okay. As soon as I picked one to put right here, there wasn't 5 choices anymore.
Yeah.
Because there's already somebody standing right here. So now there's only 4 choices.
Does that 3 represent boys?
That 3 was all the choices I had for second place. I only had 3 choices for second place because they had to be boys.
Yeah. That's what
All right, so that's the reason this is a 3 is because I had 3 choices of boys. There was, I don't know, what are the names again? Greg, Sam, and Tyler. Okay, those are my 3 choices for that. The reason this is a 4 is because there were 5 people that could have finished first, but one of them's here now. So now there's only 4 choices. And then how many choices for my next spot? Well, there were 4 choices. I used one up. Makes it go down to a 3. Tough question. This is the toughest part. Of course, we've been leading up to this with the easier stuff. All right, so let's get to your homework for today. And I'm going to pause for a second. So here's our worksheet. It is called Unit 15, Lesson 1 on Permutations. All right. I'm going to look at the size here. Yeah, it's a little bit extensive. All right. So I am going to say that, you know, these kind of like don't make that much sense if you skip parts A and B. So I'm going to say that you need to do number 1 from beginning to end. We do a lot of questions like that on tests. So that's 1, A, B, C, D, E, and F. It's all about just that one books problem. They're just asking you different questions about it. And I'll help you start it in a minute. Number 2, I'm going to say you can skip E and F. And then 3, you can skip D. And 4, you can skip D. And to keep this reasonably sized, you may skip 5 also. All right, So now let's go back to the beginning and get started together. An 8-volume set of reference books is kept on a shelf. Just think of it as volume 1, volume 2, volume 3, 4, 5, 6, 7, and 8. Okay. Then, how many ways can the 8 books be arranged on the shelf? If you don't think the order matters, then you can either just put them on the shelf or not. So there's only one way to do it. You put them on the shelf. But do you think when they ask this question about how many different ways can they be arranged, do you think the order matters? I think it does matter. Otherwise, the answer would only be 1, and that'd be too like weird to ask the question. How many ways can you arrange it? 1? That's just if the order didn't matter. This is implying the order matters. So it's like a P question, by the way. So if it's a P question, how many books were there? 8. And how many are we going to put on the shelf? 8P8. That is not 1. And it is not 0. Grab your calculator and type in 8P8. What's 8P8? It's either you're either typing it in wrong or you're typing it in right and you just don't believe the answer. 40,000 what? And I know you think that's impossible. It's true. There's another way to think of it. If there's 8 books on the shelf, couldn't you have thought of that as 8 spots for the books? 1, 2, 3, 4, 5, 6, 7, 8. You know what I'm saying? How many choices do you have for the first spot? If you just randomly pick a book, you could put how many books there? 8. Now I've used up a book, so... And do you get this is just going to be 8 factorial? Figure it out that way. Use your calculator and figure out what's 8 factorial. I betcha it's 40,320. It is. Look at that. And this is one of those things that is not intuitive. If you asked your dad, okay, there's 8 books over there, how many different ways could you arrange them on the shelf? They're going to say like, I don't know, 20, 25. And the answer is 40,000. It's not something you think is like, that's not what you expect answer, but it's true. Telling you. Yep. Think of it this way. It's almost like an 8-digit password where there's 8 numbers you can use. You can't use 9s or 0s in this password, but it's like an 8-digit password. If I'd asked you that, how many 8-digit passwords can there be? But you can't use 9s and 0s. That way we have 1, 2, 3, 4, 5, 6, 7, and 8. Okay. And you can't repeat numbers in your password. But you know that there's a zillion passwords you can type in if you have a lot of blanks, right? If your password is 8 digits long, there's a lot of things you could type. All right. Anyway, it's kind of like that. There's a lot more than you'd think. Okay. And now, wait a minute. Volume 5 has to be the rightmost book. Okay, that is blanks again, because you can't do that with a P. But I can say this with choices. If volume 5 has to be here, don't say I have 5 choices. How many choices do I have there? 1 choice for that one. Now you restart the problem and you ask how many choices do I have to put there then? 7, because I used 1 up. He's down here. There's 7 choices, 6, 5, 4, 3. And you might be like, but there's less choices now because this number will be smaller. Yeah, it's smaller because you forced us to have volume 5 at the end. So there's going to be less. All right. The blanks thing is probably what you're going to use more than this thing. But I wanted you to show you how to use the P's and C's because they are going to come up and you'll have to do some of the problems later. You'll have to use P's and C's. It's the only way to do some of the problems we do later. That was hardcore probability. If your brain hurts a little bit, that's to be expected. You'll be smarter by the time we take a test on this. Yeah. Well, it's like saying one of the digits in the password, you don't have 10 choices for it anymore. There you go. All right. That's all I got for you for today.